Let's look at example 4. In example 4, we have our table of values. From there, we're going to get our points again. Remember, this is the point 1, 2. So on my graph, I'm going to go right 1 and up 2 and plot my point. Then I'm going to plot the point 2, 5. And then 3, 10. Then 4, 17 goes off my chart, but that's okay. I think in these 3 we'll decide if we have a linear relationship or not. So I put my ruler on my first point, and I connect it to the second, and I connect it to the third. There's no way that I'm going to be able to use the same straight line and go through those 3 points. So for that reason, for this question, we're going to say this represents non-linear data. I can look at my table as well. And I look that, and I see that as every time I increase my x value by 1 each time, add 1, add 1, add 1, add 1. When I look over here and see what's happening with my y values, 2 increased by 3 to get 5. 5 increased by 5 to get 10. As soon as I see that this number is not the same as the next number, then I know that my data is nonlinear. So now I can tell from the points, and I have a way to tell from the table. So if I'm just looking at my table, I can tell you that it's not linear because as x increases by 1 each side, down the side of my table, I look at what's happening. I need a constant increase. Y, however, does not increase by the same amount each time. And I can tell from my table because of that different number on the dependent variable side, it is not increasing by the same amount each time. I won't need to graph it. I'll know that it'll be nonlinear. These points do not lie on a line.